Hi everyone, I am Gaurav and in this video I am going to talk about scheduling algorithm, its advantages and disadvantages. Shortest job first. Shortest job first is a scheduling algorithm used to prioritize tasks or processes based on their estimated or known execution time. The task with the shortest expected runtime gets executed first, aiming to minimize the average waiting time for all tasks. Advantages: minimizes average waiting time by prioritizing shorter tasks. SJF ensures they finish quickly and don't block longer tasks for an extended period. Improves throughput. This faster completion of tasks can lead to a higher overall system throughput. Fairness for short tasks. Shorter tasks don't suffer from starvation, always having a chance to be executed promptly. Disadvantages: starvation for long tasks. Longer tasks might wait indefinitely if a constant stream of shorter tasks arrives. Reliance on accurate time estimates. The algorithm's effectiveness depends on having an accurate estimates of task execution times, which can be challenging in practice. Non-preemptive implementation. The typical non-preemptive version of SJF cannot interrupt a running task even if a shorter one arrives later. Priority scheduling. A scheduling algorithm that prioritizes tasks or processes based on assigned properties. The process with the highest property gets executed first, regardless of its arrival time or other factors. Aims to ensure that important tasks are completed promptly even in a multitasking environment. Advantages: ensures important tasks are executed promptly, improves responsiveness for high priority tasks, can be customized based on specific needs. Disadvantages: starvation of low priority processes if high priority processes keep arriving, increased complexity in implementation and management, overhead of constant context switching in preemptive versions. Round robin. Round robin is a CPU scheduling algorithm that shares the processor equally among the tasks by giving each one a short burst of time in turn. Think of it like kids taking turn onto a merry-go-round. Key features: time quantum. Each task gets a maximum amount of time called a time quantum to run before being preemptive and switch to a next task in the queue. Fairness. All tasks gets an equal chance to run, preventing long running tasks from monopolizing the CPU. Responsiveness. Short time quanta ensures quick response times for interactive tasks. Overhead. Context switching between tasks can add some overhead. Advantages: fairness. All tasks get a fair share of CPU. Responsiveness. Tasks are not starved for resources and respond quickly to user input. Predictability. Each task knows how often it gets the CPU, prevents starvation. Each short task have a chance to run in a timely manner. Disadvantages: overhead. Context switching between tasks can be inefficient, not ideal for long running tasks. Frequent preemption can impact the performance of long running processes. Sensitivity to time quantum. Choosing the right time quantum is crucial for performance. Multi-level queue scheduling divides processes into multiple queues with different priority levels. Each queue has its own scheduling algorithm tailored to the needs of the process it holds. This allows for more efficient and responsive management of diverse workload. Advantages: improved response time. Responsive processes are favored in higher priority queue, leading to faster response times. Fairness ensures all processes gets a chance to execute even in diverse workload. Reduced starvation. Processes in lower priority queue eventually gets executed in higher priority queue are empty. Customization. Different scheduling algorithm can be used within queue to suit a specific process requirement. Disadvantages: complexity. Implementation and management can be more complex than single queue algorithm. Starvation risk. Processes in lower priority queue might face starvation if higher priority queue are always busy. Overhead. Context switching between processes in different queue can add overhead.